All right, welcome. We're back here into section 3.2. And here lots of, we're going to break this up into 4 days, 4 sections here. So lots of things we're going to do here using regression lines. Going to calculate the residuals, get the slope and y-intercept of that regression line, talk about a least squares regression line using the technology, how to do that. Construct and interpret residual plots, look at those and kind of see whether regression is appropriate. We're also going to look at the standard deviation of the residuals and R squared and use these values to assess how well the line works. Describe how the least squares regression line, standard deviation, and residuals are influenced by unusual points. And then find the slope and y-intercept of the least squares regression line from the means and standard deviations of x and y and their correlation. So a lot to do here. So we're going to break this up into four sections here. So this first section, we're going to kind of talk about these regression lines a little bit. And linear relationships between two quantity variables are common. So our regression line summarizes that between the variables, but only in a specific setting when one variable helps explain the other. All right, so here we go. So that would be our regression line, and we basically describe it with a y. We call that y hat if it's got that little caret over the top of it. And so it describes how this response variable y changes as the explanatory variable x changes. And they're kind of pronounced, they're in the slope-intercept form, but we say y hat is equal to a plus bx, a being the y-intercept, b being the slope, of course, as we do those. So let's go back to our Ford F-150 Super Crew, that the price is equal to the original price, I would imagine, minus 0.1629 times the miles driven. So the more you drive it, the lower the price is. And so we're going to try to predict the price of a Ford F-150 that has been driven 100,000 miles. We're going to see what we get here. So as we plot this, we have our data that we have here. We've plotted this, and so this regression line kind of comes down through here. So we're going to find the slope and y-intercept of that, let the calculator find that for us. So this is our line that we have. So basically what we're going to do is we're going to put in that 100,000 in for the miles driven and calculate, and we're going to say, all right, well, the price of that should be about 21,967. Again, as we're extrapolating from the graph, here's 100,000, you bump up here, you go over, and you can kind of see that's approximately right where we are. All right, so it's used as a predictor, as we have there. Now, can we predict the price of a Ford F-150 with 300,000 miles driven? Well, let's see what happens. Same thing. You say, oh yeah, just throw it in the formula, right? Yeah, sure. And what you end up getting is negative $10,613. So you're saying, oh, well, if I run across an F-150 with 300,000 miles, they're going to give me the truck and $10,613. Well, no, that's not what's going to happen. And so when we do that extrapolation and use this, once we start kind of going outside, really outside the data that we have, if we start going outside either above or below, sometimes those predictions just aren't accurate. You can't really extend too far beyond the data that we have. It can be used kind of as a predictor, but like I said, you can run into some weird things when you do that. So again, don't make predictions using values of x that are much larger or much smaller than those that actually appear in your data. Okay, so that's kind of a good word to the wise as we do that. So in most cases, no line is going to pass exactly through all the points, okay? Because we're going to use that line to predict y from x, errors are going to be happening. And so we're going to get x's and we're going to make errors in the y, the vertical direction. Now these vertical distance are called the residuals, quote unquote, the leftover variation in the response variable. So you can kind of see these responses, and you can see if you're close to the line, the residual isn't very big. If you're far away, it gets a little bigger. And again, you could have residuals that are positive above or negative below. So again, the residual is the difference between the actual value of y and the predicted value. So actual minus predicted is what we're going to use to find those residuals. Okay, so we just say y minus y hat, because y hat is what we put in the formula, and that's the predicted value. So that's how you find your residuals. All right, so here we go. Back to our example here as we go. So what we want to do here is we want to find the predicted price. Okay, so as we're kind of looking here for the truck that was $70,583. Well, we kind of go in there, we put that in for x, obviously, into our equation, and we find out, well, predicted, we're going to say it's about 26,759. Well, the residual is that, well, the actual price that we have, if you look over here, yeah, it should have been 21,994. So we're going to subtract our predicted. So we're going to see that we're below the line here at 4,765 is what our residual is. Okay, so that's how you find the residual. Okay, now the residual, as we would say, all right, the actual price of this truck is 4,765 less than the cost predicted by the regression line. So might be looking, if you're shopping around and getting a truck, and it might be a good idea to buy that one. All right, so now a regression line, just interpret this, is a model for the data, much like density curves of chapter 2. The y-intercept and slope of the regression line describe this model, tell us about the relationship between the x and the y variables. So now in this, a is the intercept, y-intercept, okay, and b is the slope. All right, so that's what we have there. Now, again, as we recall here, that a random sample of 16 used F-150s, that's the equation. If we interpret the slope of the regression line, and then, of course, does the value of the y-intercept have meaning in this context? So let's kind of talk about that. So the slope here basically is telling us that the predicted price goes down by, 16 cents, 16.29 cents for each mile that the truck has been driven. That's kind of basically what they say, And then the y-intercept is saying, well, that's kind of, the predicted price if it's been driven 0 miles. So if you buy it, we're assuming that the bought price is $38,257. So it does have meaning in this case. It's also possible to have a number of miles driven near 0 miles. So, it's just kind of telling you what that original price of the vehicle is. So again, just a little caution here. When asked to interpret the slope or y-intercept, it's very important to include the word predicted or the equivalent in your response, okay? Otherwise, it might appear that you believe that the regression equation provides actual values of y. So I always want to use the word predicted. Okay, this is the predicted thing is that we have here. Okay, so again, we'll work on that today. And like I said, this is the first part video of the A section, the first day. There's 3 more parts to section 3 too. So we'll get to those next. Until next time, I'm Mr. Boone.